Hello again, everybody. This is a tutorial continuing about the computers of a car with a 4.3 liter. This is called a PCM, Powertrain Control Module, abbreviated as PCM. And as you know, computers are the heart and the brains of the car. Without it, the car cannot start. Now, there are certain things to look for. When it comes to this, a PCM, just like anything else, needs a battery voltage. It needs 12 volts. You see over here, pin 20 is battery. That means it's getting 12 volts from this line into pin 20. That's the first thing that you should always check for if you have a problem. Now, as you can see, some pins are used, some pins are not used. 1, 2 are used. 3 is not used. 4 is used. All these pins, 5, 6, 7, are not used. So therefore, a PCM can have many pins, 200 pins, even more. However, we have to understand one thing. The powertrain control module is the computer, has a microprocessor, RAM, ROM, memories, all of these things. To go, when you have a check engine light, as I've seen many videos, it says to go and to just take off the battery negative. This is the other part of the PCM, as you can see. Where is it located? Mitchell tells us. Right side of engine compartment. So in other words, if I have a check engine light, and when you turn on your car, you put accessories or run, you should always look for the check engine light. Why? Also known as a malfunction light. When you see MIL, which is malfunction, right here, pin 46, that is giving, it goes on the instrument cluster or your dashboard. That means the computer is working. It has 12 volts. It's working, and it's giving you an indication of a check engine light, and it's going out. The check engine light should go out. Now, as I said before, I've seen many videos where it says, you know what, there's a check engine light. You know what we should do? We should take the negative battery, the cable, and just take it off the battery and then put it back on. That'll take care of the check engine light. Let's say the check engine light is for a misfire. Let's say you have a bad spark plug, bad fuel injector, bad compression. How is the check engine light, how is that taking off the negative battery going to help me with a misfire? If I have a bad fuel injector, a bad spark plug, it has to be replaced. Taking off the negative of the battery is not going to help. It's not going to repair the defective component. And you'll see it'll come back on in a drive cycle. So I see most of these videos where they do that. That is not the remedy. That's putting a band-aid on it, on the problem. Now, the other thing is, when it comes to check engine lights, I see all these things over here. As you see, sensors. Now, when it comes to the pins, and let's say you're not familiar with the terminology, sometimes myself, I have to go and figure out what it means, the abbreviations that they use. TP, I know, is a TPS sensor. If I'm not sure of an abbreviation, for example, let's say I go over here and it said VSS, vehicle speed sensor, which is on the transmission. I follow the line and I look where it's heading to, and that will be an indication to me what that abbreviation is referring to. If I go over here and I see AC cluster, I'm not really sure what AC means. If I go and I look at this continuation, it tells me it has something to do with the air conditioning. Same over here, AC low. Probably a reference, a low, a ground by the computer to the AC system. air conditioning system. Trans, if I go and I follow it, has something to do with transmission. This one, HO2 sensor, oxygen sensor. I follow the lines, it'll bring me to oxygen sensors. Here, over here, I'm not sure what this abbreviation is, right? What do? IAC, what does it mean? If I go over here, I see idle air control valve. That's what it stands for. So many times, if you're not sure of the abbreviation, because every make and model have their own terminology and abbreviations, follow the lines, see where it takes you. And more times than none, it'll bring you to that, and you'll figure out what it means. GEN, what does that mean? Generator, alternator. How do I know? Charging system. The alternator is the AC generator. 3-phase. So therefore, follow the lines. Okay? Now, MAF. What does it mean? If you follow the lines, it'll go to mass airflow sensor. Now, let's say you have something that's loading it down, as we spoke about before. Let's say instead of 12 volts, it gets loaded down to 11 volts. Obviously, something is pulling it down. Now, the problem is that these modules, these computerized modules, taking off the negative battery, which I just talked about, or taking out a fuse, might reset or awaken the computers. So I'm not going to take out the fuses. And somebody said, well, let me put a meter between here and here because you're putting it in series, I can measure the current. Okay, but when you take out the fuse, guess what? You might be resetting the module. That's the last thing I want to do. That means the fault will go away and eventually they'll come back, as I've seen in the past. What I could do is I can measure voltage drops. Put everything on millivolts. Put the scale on millivolts because you're going to measure very low voltage drop. Remember, if this is 11, this might be 10.6, 10.5. It'll tell me I'm losing 50 millivolts. The one that if you look at this goes to fuel injectors. This goes to a module. This goes to also the PCM, to the computer. I'm not going to follow every line because it's too big. But basically, each branch has a different purpose. This one over here of 10 amps goes to the evap system. As you see, the evap system, which is responsible for sending the vapor through the charcoal canister. Over here, all these things have to do with evap in this case. This is oxygen sensors, another thing, because they need 12 volts for the heaters. So you look at the branches where it goes to. I could put a voltmeter here on the one side and on the other side. Again, put it on millivolts to see a very small difference. If I see a difference of, let's say, 40 millivolts, 50 millivolts, and I come over here and I see 60, 80 millivolts, and I come over here and I see 90 millivolts or whatever, suspicion to me is that this is pulling too much current. Again, I don't want to take... The easy thing is to take out the fuse, right? And when the voltage goes back up, I'll say, okay, so that line is the one that pulled it down. Huh? Yeah, but when you have multiple computers and control units, it is more difficult because you're resetting things. You want to keep the problem the way it is. So therefore, I'm going to take this. If this is, let's say, 60 millivolts, this was 12, this was 11.4. I'm losing 60 millivolts. Across here, I'm going to think, okay, now this is where my problem might lie. Anywhere in these branches. Maybe this fuel injector, this. However, when you go over here, as was my experience, I come over here, there's also another one going to this fuse. If you follow it, and I don't want to go through the whole thing, but it brings us to, guess what? Ignition control module. Gives 12 volts to this, right here. 4-pin. This is responsible for triggering the ignition coil, the primary. One side goes 12 volts. Other side is triggered on and off. Probably a transistor in here. It triggers it on and off. You get a collapsing field, and then you get a voltage induced into the secondary. The other coil is called the secondary. This one is called the primary, the yellow or orange, and the other one, the green, is called the secondary. That spark will then go to, you guessed it, distributor, where it goes into each spark plug in each cylinder. So my problem was this, believe it or not, was loading it down because this goes to the 12 volt line. So therefore, you can measure ohms also, but remember there's still power connected to the fuses when you measure ohms from this. You don't measure ohms with power connected. So therefore, you have to look at the branch and put it on a lowest scale, millivolts, like I said, and look at the difference between here and here. Look at the difference between here and here. Look at the difference between here and here. And then see what has the most amount of voltage loss across the fuse, because technically a fuse has very low ohms. You should not lose that much voltage across a fuse, obviously. But when you have something pulling it down or a load, you'll see a difference in millivolts. Again, not too easy, but that's how you go about it. And now the other side, like we said, when you see all these things, an arrow doesn't mean this is an output. It just means that it's going to that system. And again, to reiterate the point of scanners, if you understand the parameters of the variables that scanners are talking about, like mass airflow sensor, IAT, pulse width modulation, all these things, then the scanner is good. But if you don't understand what they are and all the explanations or all the possible things that the scanner does, it's just get a code reader and tell you mass airflow sensor, whatever the check engine light is. However, that just guides you to a system, the sensor, the scanner. It doesn't tell you where the problem is. It might lead you to a system of mass airflow sensor, oxygen sensor. You still have to go to the connector, make sure you have the voltage. That might be the result that it's failing from something else. So always keep that in mind, right? Let's say if you have a TV at home, the TV, right? The TV has no power. You'll say, okay, maybe it's the TV. But when you check the outlet is not working to the TV. But the scanner said, TV is not working. It led you to the system. It led you to the TV. And then you check the outlet. Same thing applies here. Don't take for granted that every time it says oxygen sensor or it takes this, automatic that's the problem when that's the code. That's the system that it guides you to, it directs you to. Anyway, please go to see my channel, Automotive Electronic Schematics by Joseph, and the other channel, Joe Electronic Schematics of Auto. Please find some videos, basic videos about transistors, about auto, anything. Thanks for watching.